And take a look at this. NASA's James Webb Space Telescope has captured unprecedented pictures of a newly discovered exoplanet.
The James Webb Space Telescope revealed 6 massive galaxies that existed between 500 and 700 million years after the Big Bang, and the discovery is completely upending existing theories about the origins of galaxies.
The world's largest and most powerful space telescope has revealed unprecedented views of Jupiter.
Did you know the universe might be acting a bit like your phone's GPS when it starts freaking out mid-drive, constantly recalculating, even though it's supposed to know the way? Well, turns out, scientists are feeling that same kind of confusion. One of them, none other than Nobel Prize-winning physicist Adam Rees, recently dropped a bombshell. Our cosmic roadmap might be totally off. Thanks to the James Webb Space Telescope, aka the giant high-def eye floating out in space, we're starting to realize just how little we actually understand. Webb's latest observations, they show that the universe is expanding way faster than expected. And this isn't just a small math error, it's a major cosmic puzzle that researchers are calling the Hubble Tension, which is really just a fancy way of saying, we're stumped. But don't panic. There may be a breakthrough. In this video, we're diving into what Webb just spotted, lurking in the deepest parts of space, and how a bold new theory could change everything we thought we knew about the universe. Curious? You should be. Before we unravel the mystery, make sure to like this video and subscribe to our channel so you don't miss a single mind-blowing update. So, a team of seriously smart folks from the universities of Bonn and St. Andrews think they've just cracked one of the biggest mysteries in the universe. But here's the twist. Einstein might have been wrong. Yeah. We might have to part ways with some of his legendary ideas about gravity. Sorry, Al. No hard feelings. Less than 3 years into its mission, and the James Webb Space Telescope is already flipping our cosmic rulebook upside down. We're talking about giant galaxies showing up way too soon after the Big Bang, and weird glowing blobs scientists are now calling universe breakers. But hang on. Plot twist on the plot twist. Those massive galaxies, they might not be galaxies at all. Some experts think they're actually monstrous black holes in the making. So yeah, buckle up. This isn't just another chill space video. This is the wild story of how our understanding of cosmic expansion is being torn apart and possibly rewritten. With big drama, real science, and just a pinch of astrophysics gone rogue. Picture this. Scientists thought they'd finally pieced together the universe, like someone proudly finishing a 1,000-piece puzzle. Then, they realize a bunch of pieces don't even belong to that puzzle. And those strange ancient blobs of light Webb captured? Turns out, they might not be impossible early galaxies defying everything we know. They could just be supersized baby black holes growing way faster than expected, which honestly makes things slightly less mind-blowing, but still crazy enough to change the game. So, is the universe totally breaking our understanding of cosmology? Well, maybe not just yet, but don't go popping the champagne. We're not in the clear. There's still one cosmic curveball that's got scientists lying awake at night. The universe's favorite party trick, expanding way too fast. Let's rewind about 100 years. A guy named Edwin Hubble, yep, the telescope's namesake, made a wild discovery. The Milky Way isn't alone, not even close. Other galaxies, they're not just out there. They're racing away from us. It was like the universe yelling, "Surprise! You're not the center of anything." And this time, humanity actually listened. Now here's where it gets wild. If everything's moving apart, then logically, everything must have started super close together. Like, really close. Welcome to the Big Bang Theory. No, not the TV show. The actual origin story of the cosmos. But just when scientists thought they had it all figured out, the 1990s came crashing in like a surprise plot twist. Turns out, the universe isn't just expanding, it's accelerating. Wait, what? That's like throwing a ball in the air and watching it shoot upward faster and faster on its own. Totally backwards. To make sense of it, scientists introduced a mysterious force called dark energy, kind of like gravity's evil twin. Instead of pulling stuff together, it pushes everything apart, and it's strong enough to mess with the very fabric of physics. Cool, right? Also, terrifying. So here's where things get even trickier. Imagine you're tracking a runaway balloon. You expect it to slowly drift away, but instead, it blasts off like it's got somewhere to be. That's exactly what astronomers are dealing with when they try to measure how fast the universe is expanding. Spoiler alert, the numbers aren't adding up, and it's causing major headaches in the scientific world. So, how fast is the universe expanding? In theory, we should have a clear answer. We've got a whole standard model of cosmology for this kind of thing. But reality, it's not playing by the rules. According to the current gold standard blueprint of the universe, the rate at which everything is expanding, known as the Hubble constant, should be around 67 kilometers per second per megaparsec. Quick pause. What's a megaparsec? It's about 3.26 million light years. Translation, it's insanely far. Basically, for every 3.26 million light years you travel out into space, galaxies should be moving away from each other 67 kilometers faster every second. That works out to about 244,000 kilometers per hour per megaparsec. Yeah, space doesn't mess around. But here's where things go sideways. When scientists actually go out and measure the universe using high-precision tools, like exploding stars, supernovae, pulsating variable stars, red giants, and even cosmic magnifying glasses called gravitational lenses, they keep getting a different number, 73 kilometers per second per megaparsec. That's 264,000 kilometers per hour. Let that sink in. That's a jaw-dropping 20,000 kilometers per hour, faster than what the standard model predicts. And nope, this isn't some tiny math error. This is what scientists are calling the Hubble Tension, a polite way of saying something's way off, and we don't know why. To rule out any chance that this was just a cosmic measuring mistake, researchers turned to their most powerful tool yet, the James Webb Space Telescope, aka the new gold standard in space observation. And guess what? The tension's still there. Nobel Prize-winning physicist Adam Rees and his team at Johns Hopkins just went all in on solving the universe's biggest mystery. They didn't just look at the usual suspects, like variable stars and red giants. They went further, analyzing a rare type of carbon-rich superstars. And their conclusion? Same result. Same tension. The James Webb Space Telescope backed up what Hubble found. The universe is expanding at 72.6 kilometers per second per megaparsec. What does that mean in plain English? It means this cosmic mystery is very real. The data is rock solid, and this is not a math goof, Rees put it best. With the kind of low-key drama only top-tier science can deliver. The gap between what we see and what we expect suggests that our understanding of the universe may be incomplete. Let that sink in. Two of NASA's most powerful space telescopes just double confirmed that the universe is growing way faster than our physics textbooks say it should. And if that doesn't make your brain flip a little, just wait, because we might be heading toward challenging Einstein himself. Ah, the universe. Just when we think we've finally cracked the code, it drops another cosmic curveball. So what's actually going on here? Why does reality keep breaking the rules we thought we understood? Well, according to Rees, there are a few mind-blowing possibilities on the table. Maybe there's a strange, exotic form of dark energy messing with our measurements. Maybe there's some undiscovered particle or field lurking in the shadows of space. Or, and here's the big one, maybe we've had gravity wrong all along. Yeah, it's possible that Einstein's theories don't tell the whole story. Now entering the chat, the weirdest and possibly wildest explanation yet for the whole Hubble Tension mystery. A research team from the universities of Bonn and St. Andrews is flipping the script on everything we thought we knew about gravity. According to their theory, gravity might not actually work the way we've always believed. And get this, they think the Milky Way, our home galaxy, might be chilling inside a massive supervoid. Translation: a huge empty pocket of space. Like, really empty. Picture the universe as a big loaf of raisin bread. Usually, we expect galaxies, the raisins, to be scattered throughout. But according to this theory, we're living in a spot where a raisin should have been. A big empty hole in the loaf. Good for cosmic low-carb living. Not so great for physics as we know it. Here's how it works. Cosmic maps show that the universe isn't just random chaos. It's structured like a massive spider web made of galaxies, dark matter, and cosmic filaments, with giant empty bubbles scattered throughout. If our galaxy happens to sit inside one of those bubbles, basically a big air pocket baked into the cosmic cake, it could totally mess with how we measure expansion. As galaxies pull toward the dense outer edges of the void, it creates the illusion that everything inside, including us, is moving away faster than expected. So when we look out into space, it seems like galaxies are racing off, like they're trying to dodge a tax audit. That could explain why our measurements keep saying the universe is expanding faster than it should be. But here's the kicker. These massive supervoids, they're not even supposed to exist. If the standard model of cosmology is right, which means either the model is wrong, or we've stumbled into one of the weirdest neighborhoods in the universe. So, according to our current understanding, matter in the universe should be spread out pretty evenly. But guess what? Astronomers have spotted galaxies 600 million light years away that are speeding off 4 times faster than they should be. That's not just a minor glitch, it's a full-on cosmic red flag. So what's going on here? To really shake things up, a group of scientists decided to ditch Einstein's famous gravity model and run simulations using a totally different theory called MOND, short for Modified Newtonian Dynamics. Think of MOND as the punk rock version of physics. It was first introduced in the 1980s by Israeli physicist Mordechai Milgram, and for years it's been hanging out on the edge of mainstream science. Too weird to ignore, too bold to fully embrace. Instead of leaning on dark matter or dark energy to explain the universe's strange behavior, MOND straight up tweaks the rules of motion, especially in places where gravity is super weak, like the edges of galaxies or inside massive cosmic voids. And here's the kicker. MOND actually predicts the existence of supervoids, like the one our galaxy might be sitting in. No dark energy required. It's kind of like realizing the issue with your TV wasn't the screen, but that your remote's been programmed for the wrong brand this whole time. Now, to be clear, MOND isn't perfect. It still raises a lot of big questions, and a lot of physicists are still very skeptical. But one thing's undeniable. If MOND, or anything even remotely like it, turns out to be right, we'll need to rewrite some seriously thick textbooks. So, what's really happening out there? Are we floating in a massive cosmic bubble? Was Einstein only mostly right? Is dark energy just a fancy placeholder for something even stranger? One thing's for sure. The universe is way weirder, wilder, and more complex than we ever imagined. So here's the big what if. If Milgram's MOND theory is actually right, if gravity doesn't follow Einstein's rules exactly, then the whole Hubble tension might not be a mystery after all. Instead of juggling 2 conflicting measurements for how fast the universe is expanding, we'd only need one consistent cosmic speed limit. The weird differences we've been seeing, just side effects of how matter is unevenly spread out across the universe. It's kind of like driving through one city and hitting a ton of traffic, then assuming all roads everywhere are broken. But really, you just drove through a busy neighborhood. same roads, different conditions. Now, if Mond is going to go from underdog to top dog in physics, we'd have to throw out some of the core ideas modern science is built on, especially our long-held beliefs about gravity. Could Mond finally shake off its outsider status and rise to the top of the physics world? Maybe, but let's be real. Challenging Einstein is no small flex. It's like walking into math class and telling the teacher you've invented a cooler, better way to multiply. You'd better come with proof, and a lot of it. Still, with the universe throwing these bizarre expansion rates at us, we'd be fools not to pay attention. Whether it's Mond, some wild new particle, or something we haven't even imagined yet, one thing's clear. The cosmos is far from done blowing our minds. And when the smartest people in the universe start sounding a little nervous, yeah, it might be time to worry. Or, at the very least, keep watching. What do you think about all this? Could Mond be the real deal? Or is there something even weirder going on? Drop your thoughts in the comments. We want to hear from you. Thanks for hanging out with us. Don't forget to like this video, subscribe, and hit that notification bell so you never miss a new update from the outer reaches of space. Until next time, stay curious and stay sharp. See you in the next one.